Welcome everyone. This is another day, and today we are going to tackle the advanced React topics which we are going to integrate in our current implemented project. So, these four topics we are going to handle into this session. The first is token counting for cost analysis. We will see how to integrate LangSmith and in our project, and LangSmith allows us to analyze the total tokens and the total cost of our of running our RAG application. The second is deep evals, like we are going to add some evaluations. We are going to perform evaluations. So what is evaluations, why to do it, why it is important for a RAG application, we are going to see that. The third is adding MMR. What is MMR? This is a type of retrieval which is maximum marginal retrieval. So we are going to see that what is it and how to use it in our project and why it will be useful. And the last is chat history. So chat history we have already implemented in the previous session, but in this session I am going to tell you and help you understand it, that how we have implemented chat history in with the use of a flowchart, so that you will get a pretty clear understanding that why chat history is important and how we have implemented it. So let's get started and let's just see that what is LangSmith and how to implement it. So as you can see, we are on the LangSmith official website, and LangSmith is basically allows us to perform some traces, like tracing our LLM applications and adding some observability. LangSmith also allows us to perform evaluations on our application. So LangSmith is provided by LangChain, and if you are using LangChain in your application for handling LLMs and GenAI use cases, then LangSmith is the very good choice for you for setting up for traceability and checking whether your application is performing good or not. It provides us basically this proper waterfall model of our particular run, and if the LangSmith tracing is set equals to true, then you will get this beautiful waterfall model that okay, email agent was run in this qualified lead was run. So it is very well defined, and you will see a proper flow of how your whole project is working and where the failures are causing. So you can find failures of it, and there is this beautiful graphs of all the evaluations you are going to do. So we are going to integrate these two things, like we are going to see the whole trace of our RAG application, and we are going to see the add some evaluations in the LangSmith dashboard. So the first step of integrating the LangSmith inside our project is to create a LangSmith API key, or we can say LangChain API key. So how to create a LangChain API key? You just need to go to the basically you need to do the sign up, and in the smith.langchain.com, if you're as you see I am already signed in, so I am redirected to this dashboard, but you have to do a sign up, and after signing up you will go see a dashboard like this. But in my dashboard I have some content. Your dashboard will be empty with only this default tracing project. So how to get the API key for it? You just need to go to the settings. In the settings you will see a API key section, and as you can see I have this 3 APIs key. So for this particular project I am going to create a new API key, which I will be called created in live class. In live class I can say select this personal access token, and select any workspace you will need according to you. Select the expiration date. For me I am just using it 30 days, and I will create a API key. So here is my API key. Make sure you copy it and store it in a particular place, because it will not be visible after this after this model, you after closing this model. So just copy it and store it in some place, as I'm doing. So I'm just storing it in my notes app. You have to do the same. So I hope you have done that, and now let's go ahead and see how to integrate LangSmith inside our project. So it's very easy to integrate LangSmith inside our project. We just need to if you are using LangChain as we are doing in our project. So we just need to add some environment variables and load them into the running stream during the run of our application. So the environment variables are the first is this LangChain tracing v2, and we have to set it equals to true. So we are saying that okay, we want to set the tracing of the LangSmith equals to true. The second is we have to define a LangChain endpoint, which you have to use the same also, which is this here. And the other two variables should be unique. So you have to define a LangChain API key, which we have created minutes before this moment. And then the last is we have to define a project, like in which project we want to set up this tracing. So for now I am just writing this LangSmith live class. Okay, so this is the project I am setting, you can choose, you can set any name here, and after that you are done. So you have to just load this environment variables, load this environment file which have this environment variables, and the LangSmith will handle all the tracing and all the token counting on its behalf, because we are using LangChain here. Okay, so let's try that. Okay, so we have set a name of a LangChain project is LangSmith live class, and as you can see in my dashboard, inside this LangSmith dashboard, inside the tracing project, we cannot see this project currently. So if it ran, we would see a project with the name of LangSmith live class here. Okay, so let's go ahead and do some let's run this test.py we have created. So now I should write like Python run test.py. Okay, so I am going to run it and it will going to run. Okay, so yeah, now it is saying that okay, let's start chatting. So I will just say hello, and the assistant is saying hello. So it was working in the previous session, but a new thing is that is we are getting the tracing in the LangSmith or not. So as you can see, we are getting a tracing in the LangSmith with the name of LangSmith live class, exactly the name of the project we have set, and it is showing me okay, the run is around 3:19 p.m., which is the time of our current time in which I am recording. The latency we can also see, and we can also see the total tokens which we have used inside the particular project. Okay, we will also see the token ran in a particular run, one single run of our application, but we also see the total token we have used. Total cost also is visible. So let's dig deeper inside this project and see what is visible here. So as you can see, we have this trace which is runnable sequence. So we are using runnable sequence, as we know, for configuring our RAG application, for running a RAG application, in which you can see that in this runnable sequence the total tokens are used. Total tokens are 302 tokens, and the total cost of this run is this amount of dollars. So we have done the first thing, which is seeing the total amount of tokens and total cost we are getting. So what if you want to see, what if you are getting too much cost and you want to see why it is happening? So you will see it inside this waterfall. You can clearly see inside this waterfall, trace waterfall, that what is actually happening. So we are running this runnable sequence. This runnable sequence, what is it is doing? It is running a parallel chain, which is using the chain we have created in the previous session. This is running inside that. You can see the input was given, the hello input was given, and the output. So the context was provided using the document, using the RAG, and the input also, and the chat history also. So this was our first text. So the chat history was empty. So the output we got was like here we got the output. What was the output? So output was agent, output was hello. So you can see everything, like the chat prompt template output, like what was that, particular AI generative AI model we have used for that, the vector store retrieval call, like the documents which we have retrieved from the vector store, we can also see that. So it is very good, like, so you can see everything which is happening, and you can see the final inputs and the outputs and what is happening inside your application. So this is called tracing, and we have integrated tracing by just configuring the environment variable inside this env, and by just loading all the environment variable using this load.env okay function. So what this load.env function was doing, basically it is just using the like this methods of setting this .env particulars. Okay, so this is done. So now let's go ahead and understand what are evaluations and why it is required for any application you are using, especially any AI application, and why it will be useful for our project. So let me help you understand that with the help of an example. So here is a flowchart I have created. So before that, I want to think of these keywords. Like this is the main keyword which you will hear again and again while understanding evaluations. These are datasets. The second is metrics. The third is LLM messages, and the fourth is evaluations. So please be patient and let's understand one by one that what it is and what is the overall concept of evaluation. So what is the overall concept of evaluation? Evaluation, as the word suggests, that we are evaluating something. But what we are evaluating? We are evaluating the performance of our applications. But on what behalf? So on we have to define some metrics, like some performance metrics, some criteria which our application should pass during the evaluation on the basis of the criteria we have think of. So the criteria are called metrics. Okay, and so this is basically what we do in evaluation. We evaluate the working of our AI applications, our RAG applications, and check whether if the application is working fine and according to the metrics or not, according to the criteria or not. And if the application is not meeting the criterias, we are going to debug the actual cause, and we are going to do some changes and do some changes in the implementation so that the criteria should be passed. So this is how we do work in the industry for any RAG application or any AI application. So that is why evaluation is important. So I have given you a overview that what is evaluation, but let's go and let's see the flow of evaluations. Okay, so before understanding the flow and seeing this flow chart, let me tell you what this dataset means. Dataset is just a combination of already crafted inputs and their expected outputs. So how these inputs and expected outputs, where will it be come from? It will be came from the documents. Like in RAG, in the use case of RAG, it will be came from the documents. It will be performed with respect to the documents. So for example, we have a document related to a company employment policy. Okay, so what inputs it could have? It could have an input of what are the working hours. Okay, so what we are saying here that, okay, according to this the data we have for the company employment document. For example, we have a PDF document in which the whole company employment policy terms are written. So this on the basis of this context, on the basis of this PDF of the company employment policy, we will create a set of inputs. And we will also figure out the expected output or the desired output. Okay, so in this case, in this input we have crafted from this data, we have figuring out the expected output should be 9 a.m. to 5 p.m. So our LLM should respond like the working hours should be from 9 a.m. to 5 p.m. So this is our expected output. And this is our expected input. So we could have multiple, like hundreds of expected inputs, multiple pre-prepared inputs and expected outputs. And we will store this combination of the inputs and expected outputs inside a data set. So this combination of inputs and expected outputs from the perspective of a document is called dataset. Okay, so I hope you got what is a dataset. Okay, so now let's understand the flow of our RAG evaluation of our RAG application. So for example, you have this dataset. In dataset, what we have outputs and we have inputs. Okay, and the structure of this inputs and output, we have JSON line format. Like we have JSON objects with the key of question, and in output we have a JSON line format with a JSON object with the key of answer. Okay, so this is just an example. So this will go ahead in our RAG in our evaluation flow, and this evaluation will perform. So how this evaluation will perform? This input will go inside our application, inside our actual application. Like here we will gonna have our RAG app. Okay, this is our RAG app. So this input will go inside our RAG app also, and this will go here also. Okay, and this will go here also, like here. So here what we have in this line, we have input plus expected output. Okay, let me zoom in a bit. Yeah, so here we have inputs and expected output, and here we have our RAG app in which we have prompted the input. So our RAG app will provide us some output, which is our actual output, like the processed output of our application. So this processed output will go inside this evaluator. And this input plus this expected outputs will also go inside this evaluator. And this evaluator will use a LLM on behalf of it. You will use a LLM on behalf of it for this case, and it will judge the input, the expected output we got, and the actual output we got, and it will judge on the base of some metrics like correctness, hallucination, and then it will give us a score. For example, it give us a score of 1. So if the score is 1, means okay, the test is passed, and our expected output is pretty similar to our expected input, and it is logical according to the expected output is pretty similar to the actual output, and it is also logical to the input we have given, and it is satisfying the key metrics we have defined. Okay, so it has given 1, but if the score is given 0.3, so it means that our matrix is failing. So we can create a threshold also, like if it is giving us a value more than 0.5, then only it will pass. So this is called threshold. So we can also control that. So here what is happening is a LLM is judging on the base of a matrix, on the base of a matrix, using the expected output and input we have given, and the actual output we have got an application, and it is judging on the base of it, and it is giving a score. So this is happening, what is happening in a evaluation. So of course you can use a human also here, like in you can also use a human here, or you can use a LLM here. Okay, LLM here. So if you are using LLM here, then it is called LLM as a judge, because LLM is judging your evaluations by seeing all the expected outputs and the actual inputs and the actual output. Okay, so I am again and again saying there are some metrics. So what is metrics? Metrics are basically criterias. So there are basically two types of criterias. The first is built-in criterias and the other is custom criterias. Like you can create criterias on your own for your application, or you can use the built-in criterias which are pretty common and everybody wants to satisfy their application on these criterias. So if the criteria are built in and already provided, so it will call a built-in evaluation metrics. So here in our LangSmith we have this built-in evaluation metrics like criteria with label string QA, like question and answer, and COT means chain of thought QA, and embeddings and all. And if in that custom we can create our custom. So in this session we are also going to take a quick look at how to create a custom evaluator also, and mainly we are going to use this CO2 QA for a built-in evaluator. Okay, so I hope you understand this four keyword, like what is dataset, what is metrics, what is LLM as a judge, and what is evaluation. So now let's go ahead and integrate this flow inside our running application, our running RAG application. So for that, firstly, what we are going to do it in a simple way. Like we are going to create a notebook, Jupyter notebook, and integrate the evaluation in it. And then after that, after running all the experiments of evaluations, we are going to create a script. So I'm going to create a evaluation.ipynb, questions.ipynb. Okay, and I'm going to just select a kernel here, and I'm going to check whether it is working or not. Okay, so as you can see, the kernel is working. Now let's start creating this. So for that, what we are gonna need, we are going to load this load.env, as you guys know. Okay, and then our first step to run any evaluation is to create a data set. Okay, to create a data set. So I have already created some set of inputs and some set of expected outputs here, and I have created an array of it and just stored this inputs in a simultaneous manner, means in an order manner. Like the first input in this list is the expected output of the in the input array. The first input will be the question for the first expected output present in the output array. So you have to keep it like that. Okay, and then what I am doing, I am creating a QA pair, like question answer pair here, using this, and I'm just converting it into a data frame, and then converting it into a CSV and storing it into this data, like into this data path. So I have already tried to run it once, so this golden CSV is created. So for now, let's delete it and try to run it again. Okay, and on which PDF source, on which context, on which data I have created this input and output, I have created on based of this 2025 AI engineering report. So this is a text on behalf of which I have created this set of inputs and expected outputs. Okay, so now let's try to run it. And as we can see, this golden CSV is created, but we have to import pandas as PD here. So if in your case the pandas is missing, you have to add it inside this requirement.txt and do it. Okay, so you have to just write pandas here, and by running a terminal you have to write uv add requirements.txt. Okay, and you have to add a -r here. Okay, so you have to write just uv add -r requirement.txt, and as you can see, the pandas is as we have written the pandas here, we ran this uv add -r requirement.txt. The pandas is appended inside this project.toml, and at last we have to do uv sync. Okay, so this uv sync, now we have the pandas inside this, as you can see here. Yeah, here as you can see, pandas is also present now. So we have added the pandas now. So if you are getting the error, you have to add this dependencies in this way using UV. So already a CSV is created, the questions and answer CSV. So this is our data set, but we have created it locally. How to create it inside a LangSmith? So for LangSmith, we have to create a client basically. So how to do it? Let me tell you. So here is a code. So here what we are doing, we are importing a client from LangSmith, and we are initiating it, and then we are creating a data set name like agentic AI report goldens I have created. So I am just creating for now LLMOPS dataset. Okay, LLMOPS data set. Okay, so this is the name of our data set, and then what I'm saying, okay, client, please create me a data set whose name is this and the description will be this. So this will create a data set, and what we have to do, we have to ingest the inputs and expected output we have extracted from the context we have. So for that we just run this dot create example, and in which we have to give inputs in this format. Like we have to give an array of inputs which should have a dictionary, and it should have a key of question. Similarly for output, it should have a key of answers. It should be there as it is, and there is this dataset id which I am just fetching it using this dataset variable. Okay, so once I ran it, it will take some time and it will just give us an output that okay, it is created. So now let us verify it by going to the LangSmith and let's checking inside this evaluation. So where will you find this data sets and all? You will find inside this evaluation under dataset. Okay, under evaluation you will find datasets and experiment, and inside that you can see we have a new dataset which is LLMOPS dataset, and inside this we have examples. We have 3 examples. Okay, so the 3 examples are same which we have created inside the IPYNB file. So as you can see, for customer facing applications we have this for customer facing applications. So our inputs and outputs are already stored inside this data set inside the evaluation inside the LangSmith. Okay, so we have that. Now what is our next job to do? So for next, what we have to do, we have to run our evaluation, but for that we have to run our RAG application here. So how to run our RAG application here? So for that I have created a custom function. So let me copy it. So this function will allow us to run our RAG application inside this Jupyter notebook. So what it is basically doing, it is just defining this local file adapter class. Okay, so that we can get the buffer and all in the files in a proper format which our application expects. And then there is this answer AI report question. Like based on this report, like I have done the static loading of our data. So here I have given a static path of this file inside the data directory, and then I have defined a chunk size and chunk overlap here, and I have defined this type, like it will return a dictionary. This is our doc string. Like what it is doing, it is basically taking the input and the data path from which it have to gather the context, the chunk size, the chunk overlap, and the number of document to retrieve. Okay, and then it will return a dictionary with answer. So this we require, like in the outputs, expected outputs or the prepared outputs, what we want a dictionary with answer key. So we have configured this function in the way we got that. Okay, we got the dictionary with the answer key in it. So what it is doing, let us understand quickly. Like it is creating this like it extracting the questions from input. Then what it is doing, it is checking if the file is exist or not. Then what it is doing, it is just configuring this file adapter we have created above, and then it is like it is initiating the chat ingester. Like in chat ingester, what we are doing, we are configuring all the files, and we are ingesting the file we want to ingest inside the vector store. And then here we have given session directory equals to true, so this will be a session based data ingestion inside the vector store. Now what we have to do, we are going to build a retriever using the vector store we have created above with the ingested documents. So in this code we are doing the same, and we are using this file adapter for debunking the uploaded files by the user. And then there is what we are getting the session ID here, and then we are defining the index path, like where our files index will be created. And using this index path and session ID, we are creating a RAG. Okay, we are creating a conversational RAG by just invoking the vector store with the appropriate chain we have created inside this conversational RAG class in the previous session. So if you are not getting what I am saying here, you have not watched the previous session in a good way. So please go through it once more, or please practice the flow which we are using here. Then you will get to know what I am doing here in a proper manner. And then what we are doing, we are just loading the retriever. Like we are loading the existing retriever which we have created here, and then we are just invoking the RAG application using the questions we are getting inside this inside here, like from the data set. And chat history is empty for initially, and then just returning the output we get during this invocation. And finally we are just accepting a exception. Okay, so now let's run it and see whether if we are getting any error. So we are getting this no module name module named utils error. So where we are getting this error, let me tell you. we are getting this error because we have imported the model loaders and others, like we have imported the files present inside the utils wrong. We have to add a multi-doc chat before this utils, like during the import we have to add a multi-doc chat before all the locations where we have this utils modules. Okay, and similarly we have to do it for loggers also and exception also. For this change, just pull my GitHub code and you will get this change resolved. Okay, so I have explained you what I have done, what is needed to resolve this error. So let me resolve it and come back to you. So I have resolved the error. I have added the multi-doc chat before the import of all the utils files and all the other files where the multi-doc chat is not written. So you will face this inside the during the importing of three modules, like the logger modules, for the exception module, and for the util modules. So you have to use a multi-doc chat before the import of all the utils all the utils modules, all the logger modules, and the exception modules. Okay, so what I am saying here is, like, during the import of, let me tell you with the help of this example, like in your case it will be written like this. Okay, it will be written like this. So because of that it is giving error, because it is searching the utils, it is searching utils into the root directory of our project, but the utils is present inside the multi-doc module. So we have to write a multi-doc module here, multi-doc chat dot here. So it will just it will just see that, okay, multi-doc is present inside this root directory, and inside this multi-doc chat have I have a input, have I have a utils? Yes, I have a utils, and inside that I have a file.io. So similarly you have to do here also. Okay, and similarly you have to check for logger and for exception. Okay, so you have to check for logger and for exception also. So now let's go ahead into our normal flow and see if our application is running or not. So as you can see, our function is run. Okay, so now let's just go ahead and check that, okay, if the function with checking the function if it is running or not. So we are just giving it a test input, like for customer facing application, which company models dominate the top ranking. So this question is also based from the agentic AI report. So our application should answer. So as you can see, our application is running, and inside here after some time you will see that, okay, answer is OpenAI models dominate the field of existing, like 3 out of 4. And will I see the trace of this run inside the LangSmith? Yes, I will see, because we have already loaded the environment variable. So this is our project on which we was working, and inside that you can see this was our input, like for customer facing application, which company model dominate the most, and this was our output. So we can see the whole trace of the run we have done with our application, and what model we have used, and also on what time it takes, and the total token and all. Okay, so this is the tracing is working fine. So this is just a testing. So let me clear the output. Okay, and now what I am doing, I am just importing these two things, this evaluate function, which is going to do all the evaluation job here, and the langchain string evaluator, like it is going to be used to define the evaluation metrics on which we are going to perform evaluations. So we are importing it from the langsmith.evaluation. So let me import it, and then the other thing is, like, if you are getting the import error, you should add the packages inside the requirement.txt. okay, using the way I have shown in previously. So what we are doing here, like, we are testing that, okay, our application is running fine with all the inputs we have prepared. So the inputs we have prepared in the starting of the session, like here, we are using that here, and we are like enumerating it and storing it inside I and Q, and we are preparing this test input and just giving this test input to our function which we have created before, like here. So, and just printing it in a proper manner so that we can visualize it. So I have given a run here of our application, and let's see, like you can see that, okay, for question 1 we are getting that, okay, OpenAI dominates the field. For question 2 we are getting some answer, like here. For question 3 we are getting some answer. So for in our input we have 3 inputs, and in our output we have 3 outputs for it. So our function is running fine. So now let's see that how to so now let's see how to perform this, like how to perform. We have created the data sets also. We have created a function also for running a RAG application, Now we have to run this whole flow, like this evaluation function by configuring the metrics we want and the LLM we want, and based on that we want to see the evaluation result inside the LangSmith. So this code, the next code I'm going to write will do that. So here is the code which I'm going to do. So we are just re-importing it, which we have imported before, like here. So this is written twice, so I have to remove it. So here what I'm doing, I am just preparing a QA evaluator, the question answer evaluator. So how to define it? We have to define it inside an array. So we can define multiple evaluators here. So you can find the type of evaluators, like what the experts using, by going into a documentation and prepare a custom evaluator, which we are going to see in a while. So here you can see it is suggesting me to change the name. So yeah, we should suggest the name because the dataset name is now LLMOPS dataset. So our LLMOPS dataset is here. So we are using a evaluator which is COTQA. What it stands for? It's a built-in evaluator which stands for chain of thought question and answer. Like it will evaluate our question and answer using a chain of thought LLM. Okay. So here it is provided by LangChain. It's a built-in evaluator. So I'm just configuring it. Okay, use this. Now I'm defining the dataset name from which I want to fetch the inputs and expected outputs. And here I am running the evaluation for a RAG application. So what it accepts, it uses a evaluate function which we have imported from the LangChain evaluation. And what this evaluation function expects is it expects a function of our RAG application on which we want to run evaluations. So here this function which we have created before. So we are just giving the reference of it here. Now we are defining the data sets. Now we are defining from where you have to get the inputs and the expected outputs. So I am defining it here, and here I am defining on which criteria or on which evaluation metrics you have to perform this evaluation. So I'm defining it here. Okay, I'm giving the reference here, like use COTQA by defining it here. And now here we have to define experiment prefix. The whole this evaluations is stored inside the experiment. So this experiment prefix will help us to find it. So I have to replace this with this here. So yeah, now it's done. And we are just giving some metadata also, that what it is, like it is RAG with fires with AI engineering report, and we are already defining that the chunk size during this evaluation was 1000 and chunk overlap was 200 and this. Okay, so now let us try to run this function and let us see if it is run or not. So as you can see, we are getting some outputs of running our application, and it will take some time because LLM calls are involved in it. Okay, so it took around 23.4 seconds, and our code is ran successfully. So if it is ran successfully, we should see the evaluation results in our LangSmith dashboard. So let us go ahead and see inside these datasets and experiments. We can see we have this dataset like LLMOPS dataset. And inside the dataset, you can see a graph. What this graph tells, it tells that okay, COT contextual accuracy, like chain of thought contextual accuracy, it was 1. Like we can see the score here that it was 1. And in this experiment, the prefix we have given in this experiment, we can see the whole result. Like okay, the COT accuracy, it was correct for all the 3 examples we have given. The chunk overlap, this is the metadata which we have defined. Okay, so let us go inside it and let's see. Let's dig deeper inside it. So inside this, you can see that okay, for this question the answer was that the reference output means the actual the expected outputs which we have stored inside the dataset, it was that, and the output was that. So the COT contextual accuracy, the matrix on which we are performing the evaluation, is 1. Like okay, so it is there, and the latency is also given, that it is completed or not, the total token, the total cost of running each evaluation. Okay, so now if you want to see that okay, how this run, so you can also see every run of the evaluator. Like here you can see. Okay, so for that we need to go to home, and inside our project you can see there is this all the runs, and see that what is happening inside each and every step of your evaluation. So this is pretty powerful, and congratulations, we have you have learned that how to create evaluations for your project. So this is in this case what we have done, we have created a built-in evaluator. Okay, so now how to create a custom evaluator, the process is a bit complex and it is a bit out of scope for our video, but for your reference I have created a function which is a custom evaluator. Like it is a correctness evaluator. What it do, it just check the correctness of the working of our RAG application. So you can just see, it's just a simple prompt engineering and creating some LangChain pipelines. So you can also go through it and find out that what exactly is happening. So this is just a custom evaluator. So let me run it, and this function is by using this function, we are going to define a custom evaluator inside the LangChain. So let me run this custom evaluator here. So here, this code you can understand pretty easily. Like what we are doing, we are importing this evaluate keyword which we have already imported, and we are defining a evaluator here inside this array. This is familiar, right? Before that, what we are doing, before we are defining a COTQA, a predefined evaluator from the LangSmith. But here we have defined a custom evaluator and we are using that. Okay, so we are just giving the instance of it here. And then what we have done, we have ran this inside our previous dataset. So it is wrong. We have to run it using our existing dataset name. So our existing dataset name is LLMOPS dataset. So we have to write it here, and now we have to run this. So here you can also configure the models, like for all the built-in evaluators, LangSmith by default uses OpenAI. So for example, you want to use any open source LLM or any free LLM, API call and all for your evaluation, or any small LLM for your application. So you can play with this, and you can do like not in this metadata. You have to define it here, like here you initialize an LLM. So you, for example, you are using Grok, so you have to use Grok respective code here, okay, and choose the model. So for that purpose it is useful. So for now, let us run it again. Okay, so as you can see, it is running our custom evaluators. Okay, and we can also see combine, we can also use combine some multiple evaluators. How to combine multiple evaluators? You have to do all the things exactly same. You just increase the append the extra evaluators, the additional evaluators you want inside this evaluators key for the evaluate function. Okay, so as you can see here, I have used both the correctness evaluator, which is a custom LLM as a judge, and this LLM string evaluators, which is provided by LangSmith itself. So as you can see, our evaluation is done for our custom evaluator, and let's see inside this LangSmith whether it is running or not. So as you can see in the dashboard, we have a new graph itself of our new matrix, which is a custom matrix which we have created, which is called correctness. Okay, so as you can see, its score is a bit less from 1. So we have to go inside it and we have to check that, okay, where it is getting wrong, in which inputs I am getting a wrong answer. So for this question specifically, I am getting this reference output expected answer. I was expecting that, but I am getting this. So by giving here a look, and by also seeing all the examples here, and by seeing all the traces of it, like here you can see the complete trace, like what is actually ran here and what actually happened. So by going through this, you can get a pretty clear idea that why my RAG application is failing, and where what should I do to improve my RAG application. So this is a part of debugging, but it is only possible because you have created a evaluation inside your RAG project. So that is why RAG application is implementation of evaluation inside RAG application is important, because if you have not created any evaluators and done any evaluations on your RAG application, how you will gonna know that, okay, when the user asks this kind of question, my application will gonna fail. So these evaluations help you to build confidence and build robustness inside your RAG applications. Okay, so this is how you integrate evaluations using LangSmith. And there is another pretty cool library which is called confident.ai, like this. I have also made a video of this and uploaded it inside my channel, which is Yash Patil. Simply write Yash Patil and you will find it. So this is very good library for implementing evaluations in your project. So I have already made a video of that, so I want to try something new. So for that, I have integrated LangSmith in my project. But if you want to use this library like confident.ai, this is a very good library, and it basically gives a neat and clean docs. And as you can see, the star level, it is just kind of growing and growing. And here it's a very clean matrix, like how to create a custom matrix, the matrix collection, all the metrics and all. So this is very good. And if you want to see that how to implement this in my project, you can check out my video for deep evals inside my channel. Okay, so I think the deep eval part is also done, and token counting part is also done. Now let's move ahead and see that what is MMR actually, and why we have to add it inside our project. So now let's go ahead and understand this adding MMR. So firstly, what is this MMR? So let's write it down. MMR, okay. MMR. MMR, yeah, right. So this is our MMR. So what does it stand for? It stands for maximum marginal GINL retriever. Okay, retriever. Maximum marginal retriever. Okay, retriever. Yeah, retriever. So what is this retriever? Firstly, we need to understand what is the retriever. After we will see that what is this maximum and marginal is written before that retriever. So let's understand retriever. Retriever is a concept in LangChain, and why it is used. Basically, it is widely used in RAG applications and in other any LLM application. So what is the concept of retriever? So what retrievers do? Retrievers takes a query. It takes a query from the user, and find some data from the data source based on the query given by the user, and it will fetch the appropriate documents from the data source according to the query which was given. So which type of document it will give us? It will give us the LangChain document. Okay, it will give us the LangChain document, and LangChain document we can use it in anywhere inside our pipeline if we are using LangChain. So that's why it is pretty useful. So what is the core philosophy of a retriever? Retriever will take a query from the user. It will fetch some data from the data source based on the query which was given by the user, and it will give us the result in the form of LangChain documents. So this was the thing. But why to use retriever? Because retriever, when we use retriever inside our vector store and all, we get it as a runnable. So we can use it inside the chain with the pipe operators, with the LCL language we create during our RAG application invocation. So that's why we use retriever that much, and we do not use the general invoke function or stream function which was by default given by the vector store like Fias and ChromaDB gives us. Like you can query your vector store using the simple invoke function, but we will not be able to use it as a runnable inside our LangChain. So that is the primary use case why we use retriever, and there are other benefits also of using retriever. You can check it out in the internet, but I think the core philosophy of retrievers is confirmed. So as you can see, this is maximum marginal retriever. So it's feeling like it's a type of retriever. So there are multiple types of retriever in LangChain, but it is basically divided into two formats, like based on the data store, like what kind of data store the retriever is using. So the retriever can use Wikipedia as a data store. The retriever can use archive for the data store. The retriever can use vector store as a data store. Okay, vector store as a data store. It can use Wikipedia as a data store. So if the retriever is using Wikipedia as a data store, it will call the Wikipedia data store. If they're using Wikipedia retriever, if the retriever is using vector store as a data store, so it will be called vector store as a retriever. So according to that, there are multiple type of retriever which you can check in the LangChain document. So based on that, we can classify. Other classification can be based on search strategy. So what is this search strategy? So we know retriever search inside a data store, but it can search in multiple ways. Like it can do similarity search, but similarity search is sometimes not that much efficient. So first type is like we can do similarity search. Okay, similarity search. Okay, similarity search. And there is this other strategy which is MMR, like maximum marginal retriever. Okay, so this is the type of a search strategy in a retriever which is called maximum marginal retriever. So we already have this similarity search. Why we need this maximum marginal retriever? What is the difference here? So let's understand a problem with the similarity search. So now let's understand the difference, like why we actually need maximum marginal retriever and why the similarity search is not enough, and what is the problem here. So let's take a use case. Like for example, you have this 5 documents. What this 5 document is saying, like the first document is saying like climate change is causing glaciers to melt rapidly in Arctic region. Got it. Glaciers in the Arctic are melting. Like this is also giving some information like okay, glaciers are melting. So this is also related to climate change, but it is related to deforestation in Amazon. Okay. So this is also somewhat related to climate change, but deforestation is also involved. Okay, and the fourth is like okay, wildfires. So this is about wildfires due to climate change, and this is about rising sea levels due to climate change. So the whole documents are about climate change, but they are getting some different concerns. So for example, someone has asked some information about climate change here. Okay, I have asked about information. So for example, you have asked related to climate change. Okay, inside this where documents vector stored, and you are you perform similarity search. So what similarity search will do, it will not check for some duplicate content, and it will give you result like this. So this will be the result. So this will be the result using similarity search. Okay, so this will be the result using similarity search. So you can see that we are getting duplicate documents inside this result. So we are not getting the whole context. So what we want, we want relevant documents. Here we are getting relevant documents yet related to climate change, but we are also want diverse perspective. Like we want relevant document, but it should be diverse, so that we can cover the maximum resource we have. We can get the maximum knowledge we have related to the query and the information present in our data store, vector store. So that's why, so what we found, we want two things. The first is relevant documents. Okay, relevant documents. So so the similarity search is just taking care that okay, I should give relevant documents. But what MMR also adds a factor here, which is called, I would add a algorithmic check here, and I would also give here different perspective documents. Okay, different perspective documents. So not only MMR will see the relevant document, it will also check that okay, it is not duplicate. So MMR will help us to get the relevant document, but they should be fetched and have different perspectives, so that we can get the maximum information which is of diverse perspective. Okay, so that's why it is good. So for example, so this is the result. So this was the result from our MMR. Like here is a result from MMR if we have used MMR. So what we can see here, in MMR we are seeing that okay, Arctic glaciers are melting. Okay, this is good, but now we can see there is multiple perspective we are getting, like okay, wildfires is also involved in climate change, rising sea levels is also involved. But before using MMR with similarity search, we are getting this two duplicate documents which we do not want. So that is why we use MMR. So here we have two things in MMR. So the first is like we have to configure it, and the second is like there is a function, there is a matrix. Like in our similarity search we have k only, like how many number of top documents I want. But in MMR I have k also, I have k already. Like in MMR we have also k, but in apart from that we have also lambda variable. So the lambda variable, what lambda variable tells, so the lambda variable says that okay, if I am zero, I will give you the highest diverge perspective result. And if I am one, I will give you the I will not give you the I will not take care of the divergent of the resulting document. I will work similarly like the similarity search. So we can say that if we can create a scale here, like here I can create a line. Okay, and I can say I should create it like other side. Yeah, here. So here I can say it is fully diverge answers docs and no diverse docs. So it is like similarity search. Okay, so it is like similarity search. Yeah, so it is like similarity search, no diverse documents here, and here there is fully diverse. So we will use somewhere around 0.5. Okay, so I hope you got that what is MMR, and now let's quickly see that how to implement MMR inside our project and improve our RAG context retrieval. So how to think of implementing the MMR inside our application. So wherever we build or prepared our retriever, we have to configure it accordingly. Okay, so let's go ahead and do it. We have to go inside our config.yaml, and inside the retriever we have to write like okay, search type is MMR. Okay, and then the fetch case 20 and the lambda multiplier is 0.5. Okay, yeah, so it is done also. And other than that, we have to go inside this source, inside this retriever, and at that line number 60 I have to change this like search type to MMR, and then I have to add 2 extra lines like the fetch k and all. So here I have to write this fetch k and the lambda multipliers. Okay, so that is also done. I will also update the doc string. Okay, but also I can skip it for now. And I have to add a code of line here in the conversation like that okay, if we are using this MMR, we have to do something else. So here, if our inside that I should write like if search type equals to MMR, right? I have to yeah, right, search keyword, like I'm setting here that okay, use this too also inside my search keywords. Like I add it so that inside this search keyword I will have this fetch k and lambda multiplier, so that it will be used during the building of our retriever. Okay, so that is done. And at here, like we have to log the information also, right? So here I have to add some things like okay, search type as search type, fetch k. So like here, yeah, so this is done. Like what I am saying that okay, fetch k is equal to fetch k if only search type is mmr. If it is if search type is not mmr, just leave it, just keep it null. Okay, so this is done. And then now let us move on to data ingestion and let us do some changes there. So here we have to go here and we have to configure some more settings, like here I want to replace that. So I am saying that okay, search type is now mmr, and here is our fetch k and lambda multiplier. So we have given it inside the argument, but we have to change it inside the function also. So for function, what I will do here, basically I am creating the retriever, right? So I have to just increase the keyword arguments inside this search keywords. So I will create a new if statement. Okay, and I will just write it here. Wait a minute. Okay, so here, so if you can you can see if search type equals to mmr, then add this in the search keywords, add just fetch k equals to fetch k, which we have given above, and lambda multiplier also, and then just this keyword arguments will be passed inside the retriever building. So we will use this mmr very well. Okay, so now let's just move on to the final step, like try to run it using this test.py. So let us see that if it is ran successfully or not. Okay, so let me check it once here. Okay, so now we have to change something inside this test.py, because our test.py is configured only to use. Okay, so we need to change something inside our test.py also, because our test.py is configured to use similarity search for now, not marginal mmr. So for that we just have to change this retriever. Okay, as our load retriever we have to do, so we have to change the change inside this two functions like ci.build retriever. I have to change here, like here I have to change it, and the other way I have to change, like here I have to change here, like during the loading of the retriever. So here during the loading of the retriever I have to set that okay, please use mmr and use the lambda function as this, and this function will handle mmr because we have configured the code already. Okay, so this is done, and now let's test the code flow, if it is giving me right and if it is working or not. So you will not find that much different, but according to the logic, our fetching is working good now, and it is giving us relevant document and as well as diverse perspective document. So what is agentic AI? So let's press enter and let's see if it is giving us answer or not. So it is not providing us a context. So why it is not providing us a context? So it is not providing a context because it has the attention is all your need paper inside the context. So it is correct that it does not has the information about agentic AI. So let me ask what is attention. Okay. So as you can see, it has given us an answer that attention is a mechanism related to different positions. It can also refer to attention functions on a set of query compute simultaneously. So it is giving us the definition of attention according to the context it has. The answer can be improved a lot by setting up the prompt in a proper way and optimizing the information. But as for now, the application is working and it is using mmr as we know. So that is all, and now let's just check it that we are getting it inside our LLM or not, so inside our LangSmith or not. So here we can see that in our dataset, no, inside this tracing project, inside our LangSmith live class, we have this. Okay, what is attention we have, and we can see the vector is stored somewhere. Yeah, here is the vector is stored, and as you can see we are getting the diverse perspective documents.